Okay, so good afternoon, everyone. Today we are going to continue last week's lesson. Okay, I'll be recording. I'm going to share my screen now. Okay. Okay, so I hope everyone can see my screen. Okay. Okay, so we were left at question number 16, part A last week. So we're going to continue discussing it to question part B. Okay. So this is also served as a review. So calculate the number of moles of solid dissolved in each of the following. So we have 20 centimeters Q of aqueous nitric acid of concentration of 0.2 mole decimeter. This is negative Q. Okay. So first of all, to find the mole, we know that we have to. So this is the equation of moles. Now I'm going to write this. Okay. So the equation will most be like this. So moles would be concentration times the volume. So this is the formula to find moles. So first of all, the number of moles. The number of moles, I'm sorry about that. So we are actually trying to find number of moles. Then we have already given the concentration right here, which is 40 centimeters cube. And now we have to convert that to this decimeter cube, since it is the law to be that way. So every time we calculate a volume, it has to be in decimeter instead of centimeters. So you have to convert that. Okay, can I actually annotate here? So I have here. So we have 40 centimeters cubed here. So this is supposed to be C right there, but I couldn't write this. Okay, so now we're going to convert that. So we're going to convert them. We're just going to write this down to make this more readable. So that would be 0.040 decimeter. So don't forget to add a cube right here. It's the unit of volume. Okay, so that's supposed to be cube right there. So now we already have the volume here. And the concentration is already given there is 0.2 mole. So now we just have to times that. So we have here 0.0 40 times 0.2. So that would be okay. Wow. So 0, 0 there, 2. So that would be 0.008. This would, the unit would be mole, since we're trying to find moles. So there we have it is 0.008 mole. So this one is actually the same for question number part 2. So I think we can skip that since we already discussed lots of these problems already. So we're going to next part. Like chapter 1 is really long, has many materials. So this is a carrying out the situation. I think we can skip this since this is actually um more of a experiments, I mean. So actually you can feed this the material. So the titration is called. So calculating solution concentration by titration. About titration, this actually a really simple experiment. I mean, yeah, experiment. So it's usually used to measure the concentration of a substance by slowly adding the other substance, which is why we call it like titration. I mean the titrant, the other solution there. Usually like find the concentration, and it's actually the experiment that you probably will have to do once you enter high school. Yeah. But it's actually the experiment itself is actually pretty simple, but the calculation is the ones that we need to learn actually. Okay, so here's a work example. So we have 25 centimeter cube of a solution of sodium hydroxide is exactly neutralized by 15.10 centimeter cube of sulfuric acid of concentration 0.200 mol decimeter. Negative cube there. Okay, so this is the equation. And now we are trying to find the concentration of the sodium hydroxide solution. Okay, so here are a few steps. So step one, we need to calculate moles of the acid. So right here, we have the moles concentration volume. So the volume right here, the acid, we need to actually calculate the moles of the acid. So here we have sulfuric acid, which has a concentrate, a volume of 15.10. So this 15.10, we're going to divide this by 1,000. Why? Because we are trying to convert the centimeter cube to decimeter cube. So that's why we have to divide that by 1,000 to make this decimeter cube. And then we times this by 0.200, which is the concentration of sulfuric acid. So therefore, we have 0.00302 mol of sulfuric acid. Okay, so so for steps two, we have used the stoichiometry of the balance equation to calculate the moles of sodium hydroxide. Is it? Yeah. Okay, so now we can calculate the concentration. So this is the number of moles of solute, which is we have it right here. This one, so okay. So you're probably wondering why this is 0.00302, and now we have 006 04 instead, because we actually have here two sodium hydroxide in the equation. As you can see, it has number 2 in front of sodium hydroxide. So when we have the number 2 in front of the sodium hydroxide, it means that the mole has to be times by that number, which is times by 2. So to find the moles of sodium hydroxide, we times 0.00302 by 2, and therefore we get 0.00604. Okay, so that's the mole of sodium hydroxide. And then we're going to divide that by the following solution, which is right here, 25 centimeter cube. We're going to divide that by 1,000 first. So 25, we're going to divide that by 1,000. So there we go. Then we have it 0.0250. So this is the volume in decimeter cube already. So after we divide that, we get 0.242. So this is the concentration of this whole solution. So that's how we're going to calculate that. So here's the nose as well. So it's almost like the one that I explained already. So now we have a question right here. So this time I'm going to do this instead of usual. Okay, so first of all, for question A, the equation of reaction of strontium hydroxide with hydrochloric acid is shown below. So that's the equation. So first of all, we have 20 centimeter cube of solution of strontium hydroxide. So that's the volume. Exactly neutralized by 15 centimeter cube. That's the volume of hydrochloric acid. And just the concentration of 0.100 mole deciliter. So we're going to calculate the concentration of the strontium hydroxide solution. Okay, so I'm actually going to give you time to probably just think about this for a while. If not, it's okay as well, since I'm going to explain this later on. So just give me about 1 minute. Okay, so first of all, you're going to follow the step by step right here. So first of all, we have to calculate the moles of the acid first. So which one is the acid here? Is this strontium hydroxide or the hydrochloric acid? It is pretty obvious the acid will be the hydrochloric acid. So HCl right here, it's hydrochloric acid. Okay, hydrochloric acid right there. So you're going to find that mole hydrochloric acid. So I'm going to zoom this question out. Give me a second here. Okay. Okay, that's way too far. Okay, there we go. Here we go. So first of all, we need to write all that we know first. So we know that to find the mole, we need to times concentration times volume. So that's the formula for finding moles. And here, we already have both that we need to know. So this is the moles of hydrochloric acid equals to 0.100. So this is the concentration. I do not need to write the unit. Actually, when you're doing this kind of equation, then yes, you can write the units, but it's okay as well to not write the units because this is not the end result. It's still okay, but just don't forget about it when writing the end result. Okay, so this is the concentration. And now we have 15 right here, which is the volume. And this is not in decimeter cube. So you have to convert that by dividing it by 1,000. So 15 divided by 1,000. So that would be, okay, hold on. 1, 2, 3. Okay, I'm just going to use a calculator just not to miscount this. I'm not taking this here. Okay, so 15 divided by 1,000, that would be 0.015. So now we're going to times these two numbers. So now we have 0.0015. No. So okay, it doesn't have to be capsules. Okay, so this is the correct one with the unit as well. So 0.0015 mole. So this is the mole of hydrochloric acid. Okay, so the next step is to find the moles of the strontium hydroxide. So it can be the same. Usually it can be the same. The also one is can be the same. They have the same mole, but in this case, actually different because if we pay attention, if we actually pay attention to this equation right here, we can see in front of the hydrochloric acid, which is HCl, we can see the number 2 right here. And when it has number two, meaning that this element right here has 2 moles. So this one is actually 2 moles, 0.0015. So that's why when we're trying to find the strontium hydroxide, which is right here, it has no numbers in front of strontium hydroxide, meaning that this is only 1 mole. So therefore we have to do this. So this is the mole of, okay. So we have it right here, 0.0015. We're going to divide that by 2. Okay. Okay, so 0.0015 divided by 2, that would be 0.0025. Oh, sorry. It's actually 0.0075, not 25. Okay, so we have it 0.00. Okay, why did I write it that way? Okay, 0.00075. So there's 3 zeros there. So this is the number of mole of the strontium hydroxide. Okay, so now we find both moles for 2 of this. So now we're trying to find the, so let's see right here. So calculate the concentration. Oh, okay. But my step is going to be one step more right here. So just to avoid confusion, we need to find the volume first of strontium hydroxide, which is 25 right here. So 25, we're going to divide that by 1,000. And 25 divided by 1,000 is 0.025 decimeter cube. This is in decimeter cube, okay? Okay. So this is the volume of strontium hydroxide. Now we already find the volume. This is the volume. And this is the number of mole right here. Now we can calculate the concentration of strontium hydroxide. So in order to find the concentration, okay, I'm going to delete this part. I do that. Okay. All right. So the formula of concentration would be moles over volume. Okay. So the moles right here will be 0.00075, and that will be divided by 0.025. So it will be like this. Okay, so 0.0075, going to divide that by 0.025. So the result would be, hold on, I'm just going to calculate this first. So that would, so 0.0075 divided by 0.025, that would be 0.03. And also don't forget about the unit right here, which is in mole decimeter, with the negative cube here. So this is the concentration of strontium hydroxide. Okay, so do any of you have any questions so far about this one, or if I didn't explain everything clearly? Okay, so for question B is actually the same. I'm not sure if any of you have any questions, but if you have any questions, you can just ask me right away. You can just type it in the chat box. But if not, I'm going to continue with part B. It's actually the same method, but I'm going to do this like a lot faster than before. So okay, so right here, solution of sodium hydroxide was exactly neutralized. 25 and 25 sulfuric acid. Okay, so usually we need to find the acid first, but it's actually not about which one that we are trying to find, is it the acid or not. We're trying to find a which solution actually, I mean, in the question, which solution is stated both the volume and the concentration, so that we can find them all. For example, for question B right here, just not number, question B right here, the sulfuric acid in this question, we only know the volume, which is 25.25 centimeter cube, but we do not know the concentration. But for sodium hydroxide, it is stated here, the volume, and it's also stated, they also stated the concentration. So we are going to find the mole of sodium hydroxide first. Okay, so in order to find mole, like if you said, it's concentration times volume, and then the volume is 20, right? So 20 will have to be, you have to divide that by 1,000 first. So dividing this by 1,000 means that we change the unit from centimeter cube to decimeter cube. So we have right here. So I'm going to type this. So the moles would be, this is the moles of sodium hydroxide, NaOH. That would be 0.02 volume. I'm going to times that by the concentration right there. Concentration is 0.400. So now we have 0.008 mole. So this is NaOH, okay? So I'm gonna write this moles of NaOH to avoid confusion. So now we're trying to find moles of. So this will be the moles of sulfuric acid. It says sulfuric acid, is it? Okay, sulfuric acid. Okay, so now we're going to write this down again. Okay, so now we're going to pay attention to the equation again. So 0.008 mole is the moles, number of moles of sodium hydroxide. And we can see in the equation that and sodium hydroxide and NaOH. Here we have number 2 in front, meaning that it contains 2 mole. So when it contains 2 moles, meaning that this is actually consists of 2 moles, the 0.008 here. And on the other hand, the sulfuric acid, it has no numbers, meaning that it only contains 1 mole. So to find the moles of sulfuric acid, we have to divide this by 2. So we're going to divide this, so that would be 8. We're going to divide that by 2. So we get 0.004. So this is number of moles of sulfuric acid. So we already find these two already. So actually need to find the concentration of sulfuric acid. So now we have the moles already. We also have the volume right here, 25.25. So 25.25 divided by 1000, that would be 0.02525. So I'm gonna write this down. So this is in the similar cube. So we're going to use this number and we're going to use this number as well. Right, so in order to find the concentration, once again, it's moles over volume. So we have it like like this. So put this down. So moles of volume, there'll be 0.004. Going to divide that by 0.02525. So we actually get really long numbers right here. I'm going to write this down first. 0.1584 1584 something. So this is like a repetition number. So when we see a kind of repetition number like this, so we can just exclude this right here. So this is the concentration of sulfuric acid right here. Is 0.1584 mole decimeter to negative Q. So this is how you find a concentration. Technically, you need to find the moles of both the solute and the solution of the two elements right here in the equation. And then you also need to find, don't forget to convert the volume from centimeter cube to decimeter cube. And then after you find, I mean, usually one of them, like the volume is already stated. And in finding the moles, we need the concentration. So that's why we need to calculate the one that stated the concentration. And we can find the moles of the other element, of the other solution. And then usually after that, we can just convert, after finding both moles, we can just convert the volume from centimeter cube to decimeter cube and then just divide them just according to the formula. This is usually moles divided by volume, and then we have it the concentration. So do you have any questions so far about this question? Or is there something that you want me to re-explain? Okay, so if you have any question, we're going to move on to the next part. So unless if you have any questions about it, like suddenly you think about the question, then you can just ask me and then I will go back through it.
Then now,
Okay, okay, that's okay. So we're going to move on if you have no questions. So deducing stoichiometry by titration. So we can use titration results to find the stoichiometry of a reaction. And in order to do this, we need to know the concentrations and the volumes of both the reactants. The example below shows how to determine the stoichiometry of the reaction between a metal hydroxide and an acid. So like usual, we're going to go through the work example first. And anyway, I hope all you can actually hear my voice clearly. And I'm trying to try to speak slowly. Okay, so 25 centimeter cube of a 0.0500 mole. So this is of concentration. Solution of a metal hydroxide was situated against a solution of 0.400 mole decimeter negative Q hydrochloric acid. So we both know the concentration. This is the volume. It requires 12.50 centimeter cube of hydrochloric acid to exactly neutralize the metal hydroxide. So deduce the stoichiometry of this reaction. Okay. So we have the first step right here. So the first step, we need to calculate number of moles of each region, moles of metal hydroxide. So this is actually two of the region. Okay, let's see over here. So concentration, so volume here. Okay. So we have two actually right here. The metal hydroxide and also the hydrochloric acid. So first we have the moles of metal hydroxide first because it is actually the one that's complete. We have the concentration right here and we also have the volume right here. So the concentration will be 0.0500. There's the concentration. And then the volume right here, 25, is in centimeters. Once again, we need to convert that to decimeters cube. So we divide that by 1000 to convert that to decimeter cube. So we're going to times 0.0500 times 0.025. And here we have it 1.25 times 10 to negative cube. So for hydrochloric acid, we have it right here. Okay, so it's actually stated the volume here. I thought it's not stated. Okay, I didn't quite read the questions thoroughly. Okay, so we have 0.200. This is the concentration. I would not need to do anything with it again. And of course, 12.50. So 12.50 is still centimeter cube. So we need to divide that by 1000 to find the decimeter cube, like to convert the unit. So after you use it, after like you do this equation, and usually you don't really have to like, do the maths because usually back in my high school or chemistry exams, you're allowed to bring a calculator, so you can just use a scientific calculator to actually do this kind of equation. So we have 2.50 times 10 to the negative cube mole. So we find both moles of the two regions. Okay, let's skip. So deduce the simplest mole ratio of metal hydroxide to hydrochloric acid. So the metal hydroxide, we have 1.25, and then for the hydrochloric acid, we have 2.5. So this means that the ratio would be 1 by 2. So 1 hydroxide against 2 acid here. I'm not sure how do you say this like the ratio 1. So what if in Indonesian you can say satu banding dua. I think it's just the same, I think. So this is the ratio. I'm not really sure how you say it in English. I kind of forgot about it. So one hydroxide, this is two acid. So this is the comparison. Yes, 1 by 2. And now we need to write the equation. Okay, so I'm not sure. Did I skip a question? Sorry. Oh yeah, metal hydroxide and hydrochloric acid. So this is metal hydroxide, and this is the hydrochloric acid because it has two right there, 1/2. So that's why we have two in front of hydrochloric acid, and we do the math a little bit. So MCl2 right here, so H2 here, H. Write the equation. So this is the equation. So 1 mole of hydrochloric as ions neutralize 1 mole of hydrogen ions. As 1 mole of the metal hydroxide neutralize 2 moles of hydrochloric acid, the metal hydroxide must contain 2 hydroxide ions in each formula unit. Okay, so here's the question. Okay, so give me a moment to think about the question, and you can also figure this out if you want to do this by your own.
No, man.
Okay, so give me a second. I'm going to actually think about this first to do the equation first. Okay. Okay, so first of all, we need to calculate the number of moles of metal hydroxide used. Okay, so this is metal hydroxide. Where's metal hydroxide? So the concentration is 0.0600, and we have the volume is 20 in centimeter cube. So we need to convert this to centimeter cube. So we're going to do this fast since we only have a few minutes. Okay, sorry about that. Okay, so we're going to do this. The moles is actually concentration times volume. So concentration would be 0.0600. So that's the concentration. We're going to times that by the volume. So the volume is 20. And 20 divided by 1000, that would be 0.020. So that equals to 0.001. Okay, is it actually? Okay, it's of the additional zero actually. Actually looks confusing. Okay, so this is the number of mole. This is the number of mole for the metal hydroxide. And now we're trying to find number of moles of hydrochloric acid. So it goes the same. It's the concentration. So concentration would be 0.100. And we're going to times that by 24. This is the volume of hydrochloric acid. So 24 divided by 1000, since we need to convert the unit, so that'll be 0.024. So 0.1000 times 0.024, that is equals to 0.0024 mole. So we already find 2 moles. What is the simple ratio right here? So the moles of metal hydroxide, 12 right here. So we're going to do this. So 12 divided, or you should say by, since ratio, by 24. Okay, I think I'm just going to write the full equation just to avoid confusion. Okay, so that would be 0.0024. So here we have it. As you can see, it's pretty clear. 12 divided by 12, that would be 1. And 24 divided by 12, that would be 2. So here is the ratio, 1/2. So this is the simplest ratio. So now we have to write the balance equation. So we have M for the metals. It's already stated in the question. So metal hydroxide, I think I've actually seen this before, but just gonna write this metal hydroxide as MOH, metal hydroxide, plus hydrochloric acid is 2, so 2 hydrochloric acid. And then you're going to write an arrow here. So this is the arrow. Okay. So the result would be something like this. So here we have 2. Okay, you know what? I think there's actually something that I would like to add for the metal hydroxide. So this is a parenthesis around the hydroxide here, OH. And then we're gonna add a little 2 beside it. So basically it's this is the metal chloride, no chloride here, and then this is the H and then the hydroxide reacting. So it's like water here. So in the end, the equation usually has a water right here. It's pretty common. Okay, so do you have any questions about this so far? So we're going to end the class in a few minutes. Okay, so if you have no questions, but it's okay, you can go back to the questions in time. So this is calculations involving gas volumes. I'm going to have a little view here first. So this is a short theory or history. So yes, the Avogadro's law. Scientist Amadeo Avogadro suggested that equal volumes of all gases contain the same number of molecules. This is called Avogadro's hypothesis. This idea is approximately true as long as the pressure is not too high or temperature is too low. It is convenient to measure volumes of gases at room temperature and pressure at 1 atmosphere. At room temperatures and pressure, 1 mole of any gas has a volume 24 decimeter cube. So 24 decimeter cube carbon dioxide and 24 decimeter cube of hydrogen both contains 1 mole of gas molecule. So we can find the molar gas volume of 24 decimeter cube at RTP to find the volume of given mass or number of moles of gas and number of moles of a given form of gas. So it's kind of confusing. So we usually find the equation here to solve first. Okay. So calculate the volume of 0.40 mole of nitrogen at RTP. So this is the volume in decimeter cube, 24 times number of moles of gas. So this is actually the formula 24. So it's the same, goes the same for any kind of formula. So 24, this is number of moles of gas, which is 0.40. So to find the volume, just times that 24 times 0.40, we have 9.6 decimeter cube. So it's automatically decimeter cube. So this is the how to calculate the volume. This is at RTP. So we now have question number 23, the work example. And this is calculate the mass of methane, C4, present in 120 centimeter cube of methane. So the MF value of methane will be 16. So first of all, we need to convert this one. This is in centimeter cube. We convert that to decimeter cube. To convert that, as you all know, 120 divided by 1000, and there we get 0.120 decimeter cube. So to find the moles right here, so this is for gas, the Avogadro law right here. it usually has 24 involves. So we don't have concentration is always 24 as the concentration. So moles of methane here, we have the volume, which is 0.120. It's automatically 24, so divided by 24. So we have here 5.10 negative 3 cube. I mean negative cube, sorry. And then this is the mass, since we're trying to calculate the mass. So here the mole times the molar value here, which is 16. So 5 times 10 to the power of negative cube times 16. So there we have it, 0.080 grams of methane. So do you have any questions so far? We can actually do the question next week since um we almost end the class. So do you have any questions so far about today's lesson?
No, miss.
Okay. Okay, so I'm going to actually see how many lessons. So we have number 19 for next lesson. So I think this is actually still pretty long for chapter 1. Okay, so we are actually almost at the end of our lesson for chapter 1. We are going to move on to chapter 2. After, I think this week, I think we're going to move on to chapter 2. Yeah. So since none of you have any questions, I'm going to stop sharing my screen. Okay. So thank you everyone for participating in this class. And I'm going to give you like 5 minutes. I think all of you will have another class after this, I think. So you can prepare for your next class. If not, then you can leave the meeting. So thank you once again. Thank you everyone for participating in this class. I'm going to stop recording.